Hello students, welcome to e-learning class of Viii Public School Standard 8 Mathematics. I am your mathematics teacher Varun Chauhan, and today we'll revise our topic, that is exponent and radicals. Student, you are familiar with exponents and power. You have already learned this topic in standard 7. So exponent is nothing but it is a power of a number which indicates the time, means how many times we multiplied the base. This is written in the form of a raised to the power b, where b indicates the number of time a needs to be multiplied. So this notation we called as exponent or power, where a is base and b is exponent. Here one example, let us consider if you write 9 raised to the power 3. So here 3 indicates its exponent and 9 is a base, so which is equivalent to 729. Means when we multiplied 9 into 9 into 9, so we get 729. After that there is a power with negative exponents. So student, when we have a negative exponent, so for that you have to express that negative exponent as a minus, means when a is a base which have minus exponent, so we will express that 1 by a raised to the power b. So this is the notation for any negative exponent. Now student, here we see how to write the expanded form of rational number using powers. So here we consider a rational number which we convert into decimal, that is 1204.65, means 1204.65, that we have to express in expanded form. So for that, here we'll write it 1000 plus 200 plus 4 plus 0.6 plus 0.05. So that will write in the form of exponent, that is 1 raised to the power 3 plus 2 raised to the power 2 plus 0 raised to the power 1 plus 4 into 10 raised to the power minus 1, that is of 1 by 10, and 5 raised to the power, that is 5 into 10 raised to the power minus 2, that is in the form of 1 by 100. So like this we can express a rational number in the exponential form. Now after that, here are some laws of exponent. So student, let's see, there are many laws, so we'll see one by one each and every laws with example. So student, the first law of exponent is that exponent with like bases. Here first law is like that a raised to the power m into a raised to the power n, where exponents are different but base are same. So for that, here we write a raised to the power m plus n. So similarly, when the same base is in division, so we'll write that a raised to the power m minus n, means when the base having their different exponent and it is in the division form, so we have to subtract their powers. Similarly, if we fill that exponent in multiplication form, so we have to add these powers, that is a raised to the power m plus n. Here are one example, that is 2 raised to the power 3 into 2 raised to the power 7, means here we'll add this exponent, so we get answer 2 raised to the power 10. And when we divide these numbers having the same bases, so we get here 2 raised to the power 7 minus 3, that is of 2 raised to the power 4. Student, another law of exponent is power of a power, means when we have a exponent in the form that is a raised to the power m, which is raised to the power n. So means when we have a power which having one more power, so we'll write that one as a raised to the power mn, where m and n are the integers. So here we take one example, that is 2 raised to the power 4 raised to the power 3. So here we have to multiply this power, so we get 2 raised to the power 4 into 3, that is of 2 raised to the power 12. If any number having their power that is 0, so we'll write that a raised to the power 0 which is equal to 1, means any number having the power 0 is always 1. The next law is exponent with unlike base and same exponent. So here we have a law that is a raised to the power m into b raised to the power m with same exponent but having the different bases. So for that, here we will write a into b, which is raised to the power m. For example, we have 2 raised to the power 3 into 5 raised to the power 3. So for that, we'll multiply 2 and 5 and write the common exponent for their product, that is 10 raised to the power 3, which is equal to 1000. Student, here now we'll see the uses of exponent. So when we express any large number or very small number, so we'll use the exponent to make that large or small number, or to denote that large or small number in the form of standard. So for that, there is example of large number, that is, it is a number 150 billion. So if I want to represent that number, so I want to shift the number of zeros with their decimal places after one digit, that is, so it convert into a standard form, that is of 1.5 into 10 raised to the power 11, because I shift 11 digit after 1 towards right after the decimal points. So this is the standard notation for this number. If I want to express a very small number, that is of 0.000007, so for that I want to shift that 7 towards left after decimal point, and the power should be negative. So the answer is 7 into 10 raised to the power 6, because I shift 6 digit after that decimal point towards left hand side. So this is the uses of exponent. Student, here are some example based on today's topic. So first one is find the multiplicative inverse of 3 raised to the power minus 3. Here we have to write multiplicative inverse of these numbers. As we know, multiplicative inverse when we write, so we just interchange their denominator and numerator. So we'll express that 3 raised to the power minus 3 in the form of 1 by 3 raised to the power minus 3, which is equal to 3 raised to the power 3, that we write by using a raised to the power minus b, which is equal to 1 by a raised to the power b. Similarly, we'll solve second one, that is of 10 raised to the power minus 10. Now the second solved example is expand the following using exponents. So as we already seen how we express any decimal number, so for that we just write each and every digit after decimal point in expanded form. So after 0.05, that 5 which will write in the form of 5 by 100, then 2 by 1000, and 3 as a 3 by 10,000. So then we'll write 5 into 1 by 1000 plus 2 into 1 by 1000, that 5 into 1 by 100 plus 2 into 1 by 1000 plus 3 into 1 by 10,000, that is in the form of 5 raised to the power minus 2 plus 2 into 10 raised to the power minus 3 and 3 into 10 raised to the power minus 4. Similarly, you can solve the second one, that is 32.005. Student, similarly, you can simplify the given example using exponential laws. So in this example, you have a same base, that is of minus 5, having the different powers, that is 2 and minus 3. So for that, when we have a same base with different exponents, you just add their exponent, that is of minus 5 raised to the power 2 plus minus 3, which is in the form of minus 5 raised to the power minus 1, that is of minus 1 by 5. Similarly, you solve the second one. Now student, there is example of power having a variable, that is in the form of k. Now here we have to find the value of k, which is minus 2 raised to the power k plus 1 into 10 raised to the power into minus 2 raised to the power 3, which is equal to minus 2 raised to the power 7. So here we observe one thing, that is their bases are same but the powers are different. So we know when the bases are same and the powers are different, so we have to add their powers when it is multiplied. So for that, we'll write minus 2 into 10 raised to the power k plus 1 plus 3, that is of minus 2 raised to the power k plus 4, which is equal to minus 2 raised to the power 7. Here we have a same base in the left hand side as well as in right hand side. We just equate their exponent, so we get here k plus 4, which is equal to 7. From that, we find the value of k, that is equal to 3. Student, this is today's assignment based on exponent and radical. So you have to note down this assignment in your mathematics copy and solve it. Students, I hope you enjoyed today's session. We'll meet again with another video. Till then, stay home, stay safe. Thank you. Have a nice day.